Good evening, Professor Coiler. This is Suzanne Boemi. I normally start my videos off on me and then I show you my charts along the way. However, I thought I would do it different this week and I will show you my PowerPoint presentation and talk you through the presentation. Unfortunately, my devices do not have the option to be able to flip camera to video. So I will talk you through my presentation this week while I show you my PowerPoint. So this week we're looking at renewable and non-renewable energy. My data table 1 was mass and density of distilled water. I had a mass of 9.59 for distilled water. The density was 0.959 and my starting temperature was 20 degrees Celsius. So the data table 2 is the calorimetric data, and I started an empty fuel canister at 44.60. The initial mass was 25.63. The final mass was 24.81. The initial temperature again was 20, and so my final temperature when the experiment was over was 44. The tea candle, my initial mass was 10.20. My final mass was 9.96. Again, my initial temperature was still 20, and my final temperature was 33 degrees Celsius. So data table 3 was calories released per gram of fuel. So the difference in the fuel canister temperature was 24 degrees Celsius. The calories absorbed by water was 2301.6, and the grams of fuel consumed was 0.82, and the calories per gram was 2806.8. For the tea candle, the difference in temperature was 13 degrees Celsius. The calories absorbed by water was 1246.7. The grams of fuel consumed was 0.24, and the calories per gram was 5194.6. So putting this all together, we were asked which fuel was more efficient, and here in my experiment, the tea candle is a saturated hydrocarbon, produced 2387.8 more calories per gram. Therefore, it was more efficient. Both the tea light and the canister had oxygen to allow it to burn. However, the tea light did better with the room oxygen. Something I want to note here, and I'm not quite sure, my science kit, I'm having some interesting results with my science experiments here, but my wick did not burn. I had the 30 milliliters of isopropanol as instructed. I had pulled the wick out enough that I could start the wick, the initial burn of the wick. However, the wick would not stay lit. So I stopped the timer. I pulled the wick up higher, thinking I did not have enough height on the wick. And again, I could get an initial burn, but it would not stay lit. So I had to hold the flame to the wick for the whole 5-minute experiment, which I know that, that just might not have produced the right temperature in the end, holding that flame there. However, that's what I had to do. I could not get the wick to burn for some reason. So just want to make a special note there. So we were to explain the difference in the efficiencies of the fuels that were tested. And I said the isopropanol is a saturated hydrocarbon that burned with a low flame and at times had an inconsistent flame, and that could have been, again, because of the issue that I was having with the wick. However, there was enough fuel in the canister to keep the isopropanol burning for a while. So knowing that isopropanol would have burned, if I didn't even have to hold the wick there, it would have stayed a consistent burn until the isopropanol ran out. The tea light candle started off with a high flame. However, once the wax was burned off of the wick, the flame was reduced, but still burned at a very consistent rate and never faltered one way or the other. The diethylene glycol is an organic compound used as a fuel in heating cans. Based on its structure and your data recorded in Table 3, how do you hypothesize its energy efficiency compared to isopropanol and the wax? So here I said I do believe that the diethylene glycol would have burned at a consistent rate and burned more fuel than the isopropanol and tea light did. The heat temperature would have burned hotter than the other two chemicals. However, therefore, the increasing the overall temperature of the water. So essentially, we would have seen a higher degree in Celsius burning the diethylene glycol. So what are the possible sources of error in this experiment? And this just kind of goes back to what I was explaining earlier, that there's room, human error is always going to be sources of an error. There were many opportunities for human error, as I had to measure the liquid of isopropanol to pour into the can, which then I poured into the funnel, and there could have just been some room for spillage there. And all the isopropanol might not have gotten into the can as needed or required. So that could have been a potential. It did not happen for me, but could have been a potential. To reduce the errors in the future, the metal canister could possibly come pre-filled with the isopropanol. Therefore, the can would measure exactly as needed for this experiment. Additionally, as I had shared, my wick did not stay lit the entire time. I'm not quite sure what happened there. I had to hold a flame over the wick to warm the water, which then that could have altered the outcome of the experiment there. I played with the wick, pulled it out, pushed it in, played with it a couple of different ways to try and get better results. I am not sure what could have been done to allow the wick to burn at that point, other than holding that flame pretty consistent with it. I was instructed to use aluminum foil, which is a conductor of heat. So perhaps a lid could have been built to fit the glass beaker to allow the thermometer to fit as well, to create a tight seal. With that aluminum being a heat conductor, it could have increased the temperature of the water, not necessarily to a full Celsius. However, it definitely could have made a difference or an impact to the overall temperature. And then the initial weight of the can, along with any of the other products that we were given, can vary from kit to kit. So there's no way to really determine a consistent weight across the board with the weight of the can or the wick. The experiment, what could have been done different or to reduce these human errors in the future? The experiment could have been conducted more than once. And it could have been conducted in a controlled environment, such as a science lab, was what I had thought of. So in conclusion, I initially thought that the isopropanol would have burned better and more consistent. It is considered a biofuel, just as gasoline is. And when I think about gasoline burning, it gave me the understanding that it too would burn better than wax. Henai and his group says isopropanol is one of the secondary alcohols that can be produced by microbes, and it can be used as a biofuel to partially replace gasoline. So that's why it gave me that initial thought that perhaps it would burn better and burn quicker, and I would go through more isopropanol than what I did. Interestingly enough, though, in the end, it was the wax candle that produced more calories per gram, making it more efficient. So let me know if you have any questions. That is my presentation for this assignment. Thank you so much.